Hello again, this is Jordi from Dapcom, and I will show you in this time how to use some of the advanced options of FAPEC and WinFAPEC. As in the other video, let's just open WinFAPEC. In this case, this is obviously for Windows, but I will show you in another video how to use these advanced features from other operative systems like Linux and Mac mainly, and also from the command line from Windows itself. In our case, let's go again, as in the other example, to the folder where we have some data that we want to compress. In this case, let's specifically add one by one the files that we want to compress. For example, let's include this one. Let's include this one as well. Some raw photo. Then going up one folder in the maritime, let's add the KMall, the WCD, the KMWCD, some EK80, some HiSAS data in XTF format, and some Side-Scan Sonar in XTF format as well. Now that we have chosen the files that we want to compress, let's click in Compress again. And now this is mainly for maritime users, but others can see how it works as well. We can go to the mode-specific options, where you can see the several algorithms that FAPEC includes. The usual default one is the automatic one, where you have some explanation here. General options, for example, the chunk size, you can just leave the default. Let's forget about this one. These other options you can also forget. Typically, this is for more advanced users. And then the others, most of them just have an effect in case you do not use the automatic mode in the compression. So let's ignore all these ones for now. Except I think it's just FAPEC LZ. Here, the level, it's the compression level, like in ZIP or WinRAR. The higher, the better. The higher, the slightly slower, but typically better compression ratio. So you can just put it at a high level if you wish. And then we go to the maritime options that do have an effect even when you are running in automatic mode. Let me explain this as briefly as possible. Let's start with the KMall data. You may know that there are some datagrams in the KMall format, which include the bathymetry. This is typically the .kmol files, not the .kmwcd files. In the soundings, which basically reveal the bathymetry, in 0, it means lossless. You perfectly recover the original file. But you can push that up to level 7. You see here that a small warning has been activated in red. It disappears when none of the options have any lossy level activated. In the specific case of the soundings, you can go up to level 3, between 3 and 4, and you should not even notice any loss at all in your data, whereas you can increase the compression ratio. You can reduce further the compressed file size. This is the case because FAPEC applies a kind of smart compression algorithm that basically just removes the noise in the acquisition of the data, just the instrumental noise when you acquire the data with your sounder. So you could safely go to 3, and even in your processing programs, your data analysis, exhaustive programs, and whatever, you should not notice anything. But better, we recommend that you test that beforehand, before applying and setting these compression options by default in your case. The seabed image, also contained in these MRZ datagrams, can also be compressed with lossy mode. You can go as high as level 16, which will basically mean removing completely the seabed image information, so be careful about that. Again, if you exploit in your programs the seabed image samples, first test how it looks like and how it performs with different compression levels before really activating that by default. Let's just put a level 6, for example, in this case. Then we move to the water column, the KMWCD or integrated KMall plus KMWCD diagrams. The MWC, sorry, diagrams, you can compress them with the losses on the amplitude, on the usual fan view, the values of the samples, of the reflectivity values that you get from the sounder. You can also quantize those values so that you see a coarser aspect in the water column. You see some less contrast in the fan, so you can increase that as much as you wish. We have seen that typically with some experiments, with level 3, 4, you will barely notice anything, because typically, as you know, you stack several fans, several pings into one single image when you process the water column. So by stacking those several fans, it kind of compensates these losses that you have applied in compression. So again, you can experiment with that and see how it looks like in your case. The phase samples in the water column, again, these, in case you are acquiring them, you can even destroy them. You can completely remove them when you go up to 16, or if you find that you don't really need the full accuracy of the phase samples, you can put a little bit of losses, for example. And finally, in this case, this aggressiveness in removing useless water column samples, FAPEC applies a smart analysis of the water column information and determines those samples, sample by sample, that seem to be below the usual noise level. And when that happens, by determining some percentiles in the values of the samples and so on, it just sets those samples to 0. It destroys those samples. So that when you apply even level 1 here, in this case, you will activate this algorithm, and in principle, it should just remove those samples that are really useless in most of the cases. But once again, just test and evaluate. You can go as high as 16. It's basically moving between different quantiles or percentiles of the histogram of samples that you have in the water column. So this is quite aggressive. This is quite conservative, a level 1 or 2. This one, we think that it should be quite safe to use, but again, just test and evaluate. The classic historical.all bathymetry data, it doesn't have any option. The classical water column, the old, not KMall, water column format also has some lossy option. Again, the higher, the worse the quality that you will get. So again, be careful, evaluate, test and evaluate how it goes. XTF for HiSAS and Side-Scan Sonar, you can also apply some losses up to 12. Experiments tell us that you should very safely go up to level 4, 5, perhaps even 6, and you should probably not even notice anything in the reconstructed image of the sea bottom. And finally, in EK80 data, this is very interesting because, as you may know, the EK scientific echosounders store the data in floating point values. So here, they are kind of oversampled, so to speak, and in most of the cases, you can apply levels of 4 or so, which remove some of the bits in the floating point values of the samples that you are acquiring in these EK sounders. And in most of the cases, I would say in all of the cases, you can go to level 4, 5, even 6, and you should not notice anything at all, because the full structure is kept with the real and imaginary samples, or if you prefer, I and Q samples. The several sectors that you acquire, the several frequencies that you acquire, everything, the full structure is kept, and just some of the bits of the values are removed. So you may experiment with that, with the most demanding analysis that you may do in your case, in the specific kind of datagrams that you acquire. and see if that really affects your case. But again, we think that from some colleagues, from some experts, it seems that level 4 doesn't notice anything even in the most demanding analysis. Typically, you may even go up to level 10, which compresses quite a lot more than in lossless. And in this case, many analyses will still go perfectly fine. Be careful about this. When you move from 10 to 11, it does a sudden change in the losses, so you will see quite a significant loss from level 10 to level 11. And when going from level 15, which is the worst one, keeping the full structure, to level 16, this is the extreme losses case of FAPEC for EK80. In this case, if you just care about the overall water column profile, so to speak, along the track that you have been acquiring on your vessel, if you just care about that, you will not notice anything again. But it will destroy all of the information between the real and imaginary values or the phase information, if you prefer. So many of the analyses that you may need on your data will not be possible in this case. So be very careful with this loss level, which is the maximum one. But again, if you just want to get a very tiny file to be able to get the overall profile, this is your option because it compresses the file a ratio of even 20 or in some cases even 40. So just test that, okay? Let's leave the things in these values. Click accept. Note that, again, I forgot. When you go here, make sure that this checkbox is activated because this will be the only way that the options that you have chosen are used in the automatic mode. Okay? And then last thing, you can also activate this basic analytics option, which will enable some very quick and simple analysis of FAPEC on the fly while compressing the data, and it will generate a small text file with the information extracted from these files that have been compressed. Okay, let's go. We click on compress. You see that the log file is compressed without any loss. The FASTQ, of course, the genomics cannot be compressed with any loss. We may apply some losses to the quality values and so on, but we don't do that yet. We get a ratio of 2.6 in this specific file. It strongly depends on the instrument. Then raw photography again, and you can see that this KMall file is being compressed in lossy mode. And you can see that we get a ratio of above 4, which is very interesting in this case, despite I think that I have left some conservative loss options. So it's very interesting. In this case, the speed has gone down just because the disk is struggling a bit, but in your computers, most probably it will be much, much faster than this. Typically, we are above 100 megabytes per second. And in some cases, depending on the disk, on the computer, and on the algorithm used, you can reach 1 gigabyte per second in compression speed. Okay, you see another file here, the old water column format, again in lossy mode. You see the warning here. The new format, KMWCD, again in lossy mode. You see that we get a ratio of 3.4. Once again, with relatively conservative options in this case. And almost finally, this EK80 again in lossy mode. In this case, we reach a ratio of 1.8. It's struggling a bit. While it's continuing, let me mention that I will explain that later. You can also choose some specific compression mode here in this option of WinFAPEC, and what it will do is to use just that given specific compression algorithm for all of the files that you have chosen. So if you choose a non-automatic mode here in WinFAPEC, make sure that you are just compressing the same kind of data always. Otherwise, you may be applying some invalid mode in some cases, which most probably will lead you to suboptimal compression radius. So just be careful about that, okay? All right, so the compression has finished. You can see here a summary indicating that these following parts have been compressed in lossy mode. So just as a recap of where you have applied some losses, you just accept and that's it. And when you want to decompress the files, there's no change here. You can go to the documents where we have stored, oh no, sorry, I think that we have stored that in the same USB drive. That's the reason why we have been running so slowly in this case. And that's basically it. These are the professional options to apply some losses, especially in maritime data. And then from that, in another video, I will show you how it looks like in the specific case of the water columns when you have applied those lossy compression options, okay? And that's it. Thank you.